Today we're going to be talking about finding the trig functions of special angles. So let's start with our first problem. Find the exact value of the six trigonometric functions for theta equals 120 degrees. Initially, what we like to do is to see what that 120 degree angle looks like. So, on our coordinate plane, let us draw out 120 degrees. Of course, our initial side is along the positive x-axis. And 120 degrees would result in an angle whose terminal side is in quadrant 2. Which means our angle of 120 degrees rotating counterclockwise would be right here. The next step or thing we need to look for is what our reference angle would be. In order to do that, we need to draw our reference triangle, which is the triangle formed by dropping a perpendicular line down to the x-axis. Our goal here is to find that angle, which is our theta prime, reference angle. Now, if we think about this for a moment, this angle right here is a straight angle, which is 180 degrees. In order to find the reference angle, right here, we take 180 degrees and subtract out 120 degrees, which results in our reference angle of 60 degrees. Now, since this angle right here is perpendicular, it makes a right angle, which results in our last angle being 30 degrees, creating a 30, 60, 90 right triangle. Now, remembering back from geometry, the 30-degree angle is the smallest angle, which is opposite the smallest side. If we remember that the three sides in a 30, 60, 90 triangle are in a certain ratio, whereas the side opposite 30 would be a length of 1. The side opposite 60 is a length of the square root of 3, and the side opposite the right angle, or our hypotenuse, is 2. Now, one thing before we move on is we have to remember that we're in the second quadrant. And in the second quadrant, we're moving in the negative x direction, which makes x -1. So let's go back and record these values now. X equals -1. Y equals the square root of 3. And R equals 2. At this point, we're ready to find our trig functions. So we have to remember that our definition of what our definitions of the trig functions are. The sign is y divided by r, or in this case, the square root of 3 divided by 2. The cosine is x divided by r, or in this case, -1 divided by 2. And the tangent is y divided by x, which is the square root of 3 over -1, which we obviously simplified down to the opposite of the square root of 3. Now remember that the second three trig functions are reciprocals of the first. So the cosecant is the reciprocal of sine. So it would be r divided by y, which is 2 divided by the square root of 3. Now we don't leave radicals in the denominator, so we have to rationalize by multiplying by the square root of 3 divided by square root of 3, which equals 2 square roots of 3 divided by 3. The secant is a reciprocal of cosine, which would be r divided by x, which would be the opposite of 2 over 1, which simplifies to be -2. And finally, the cotangent of theta, which would be x over y, which is -1 divided by the square root of 3, which again we have to rationalize by multiplying by the square root of 3 over the square root of 3, which results in the opposite of the square root of 3 divided by 3. And there you have it, how to find the exact values of the 6 trig functions for any special angle.